So this question has a astronomical object emitting pulses at regular intervals. So what we've got is periodic release of energy. So that could be attributed to a frequency. So the graph shows variation of intensity of radio waves received from the pulse. So what I've done is I've just looked at the peaks. So there's the first peak, I would say, where we start. There's the next one, there's the next one, there's the next one. I can argue there's that one there. I'm trying to keep the same kind of distance, and it slightly matches that the distance is quite consistent, or the time is quite consistent between the peaks. So that's once where the one pulse, let's say, starts and finishes, and so on and so on and so on. So what we've got is 11 pulses in 15 seconds. Now we know frequency is to do with the number of cycles or number of oscillations per second. So we can extend that to this. So it's the number of pulses in 1 second. So we know in 15 seconds, there are, I've just counted them up, 11 pulses. And we know frequency is the number of oscillations, vibrations in 1 second, or in this case, pulses in 1 second. So we know there are 11 pulses in 15 seconds. So divide that by 15 to get number of pulses in 1 second. And we get 0.73 hertz, which falls between zero point 0.7 and zero point 0.8. So this is a simply straightforward a frequency question. And it doesn't make a difference what the context of the question is. As soon as they've asked you to show the frequency, you need to look for cycles or and time period. Okay, so in this scenario, we can see that we know peak to peak is 1 cycle. So that's what I'm trying to spot. We haven't got a sine wave or a cosine wave that makes it easy for us to spot the start and the end of a cycle. But nevertheless, we can look for the start and end cycle by just looking at the intensity graph and seeing, okay, there's quite a lot of peaks, and the distance between a peak is 1 cycle, and we've got many cycles between 15 seconds. If you count them up, that's 11 pulses in 15 seconds, and which is why I've done to find how many pulses in 1 second. So we have to divide by 15. You could equally find the time period here. So you could say that the time for 11 cycles is 15 seconds. So what's the time for 1 cycle? So you would have done the opposite. You would have done 15 divided by 11. And then to find the frequency, you would have done 1 over that, which is the same thing here. So whichever way you approach it, it ends up with the same answer. Hope this helps.